everyone, welcome to STEM with Simba. This is going to be our first activity this week, so let's go over a few things. STEM stands for Science, Technology, Engineering, and Math, and that's what I went to school for. Today's activity will be Oobleck, and we're going to learn some more things about Oobleck in a few minutes. To make Oobleck today, we'll need a couple of materials. We'll need a half-cup measuring spoon, a 1-cup measuring spoon, some water, just out of the tap is fine, some cornstarch, something to stir with, a bowl, and some food coloring, just for fun. Now before we start making Oobleck, I'm going to give you guys a little bit of information that I think you should know about it. So, let's start with, what's everything around us made out of? Well, the answer to that is matter. And matter means everything that has mass, that weighs something, that you can feel when you pick it up, and everything that takes up space. So that would be me, that would be you, that would be this shirt I'm wearing, and the chair I'm sitting on, and everything around us that we touch and interact with every single day. But what are some examples of matter? Well, matter has 3 states: solid, liquid, and gas. Solid is something that has a definite size and shape, kind of like this measuring cup. It doesn't really move, it's always the same shape, it's never really changing. Liquid is something, like water, that has a definite size, but it does not have a definite shape. So when I lean this glass back and forth, it kind of sloshes around, so it does not have a definite shape. And a gas is something that does not have a definite size or a definite shape. Think steam, like when you make a cup of coffee, or when you're boiling water for pasta, and all that stuff comes up off the water when it starts to boil. That's a gas, called water vapor. Whereas, in a solid form, water would be ice, like ice cubes. Now, let's stop and think for a second. Do you think something can be more than one state at once? Or what makes something change between these 2 states? I want you guys to keep that in mind as we go through this experiment. But let me tell you, Oobleck is not going to act how you expect it to. It's one of those things that you think it'll behave one way, but maybe it doesn't. Maybe it behaves another. And in other words, that's a non-Newtonian fluid. Let's make this and find out some more later. To make Oobleck, our very first step will be measuring out 1 1/2 cups of cornstarch. So as you can see here, I've got them measured out already. I'm going to take them and dump them into our bowl. Next, I measured out 1 cup of water, and now I'm going to add a little bit of food coloring in there to make things more fun. Next, I'm going to slowly pour that into the bowl, and I'm going to stir until I think that there are almost no clumps left. So that's what I'm going to use my fork for. So I've been stirring now for about 3 minutes, and as you can see, I don't have any clumps of this white stuff that we called cornstarch left. It's okay if it feels a little bit hard to stir or looks a little funny. Now, what do you guys think this is? To me, right now, this looks pretty liquidy. What happens when I put my hand in it? So if I put my hand in it, do you see that? It runs onto my hand slowly, like a liquid, and it runs out through between my fingers. Now I want you guys to try putting in your hand slow. Well, that feels like a liquid, doesn't it? And taking your hand out slow. But what happens when I put my hand in fast? Oh, it's hard. Isn't that weird? I'm going to grab a smaller bowl to show you guys better. My Oobleck pours, just like water would, into this smaller bowl. So I've poured my Oobleck into a smaller bowl to give you guys a better view of what's going on. So if I stick my fingers in slowly, well, they go in just like it's a liquid. If I pull them out slowly, the same thing happens. Well, what if I try to go fast? Well, do you see that? I can't even get my hand or my fingers into the liquid. It's behaving like a solid when I try to do something fast. Well, that's odd, isn't it? Can you think of anything else that behaves this way? I don't think that I can. If I tried to shove my hand in a glass of water really fast, I would just splash myself and make myself wet. Wouldn't do the same thing. So let's learn a little bit about viscosity. So once again, it's the rate at which a fluid flows. So things with high viscosities that flow slowly are things like peanut butter and molasses. Peanut butter's viscosity is so high that it actually behaves like a solid. Almost like Oobleck when you're putting some pressure on it, when you're hitting it hard, moving fast, right? But with a low viscosity, there's things like water. They flow really easily, they flow really fast. So, well, what makes water and Oobleck so different? Well, to start, water is a Newtonian fluid, which means its viscosity changes with temperature. So let's think for a second. Room temperature water, like you would get out of the tap, well, that's got a low viscosity, right? It flows pretty fast. But what about when it starts to get colder and colder and colder? Let's think of a slushie for a minute. Well, that flows slower than water, right? Definitely. It has a higher viscosity than water does. So as you can see, its viscosity is changing with temperature. Oobleck, on the other hand, is a non-Newtonian fluid. That means it does not follow Newton's law of viscosity. And Newton's law of viscosity is what I just said a moment ago, that the rate at which something flows, or its viscosity, changes with temperature. Well, Oobleck, that's not the case. Its rate of flow, its viscosity, that changes with pressure. So if I put a very low amount of pressure on it, it has a low viscosity. It flows much more easily. We saw when I poured it from my large bowl to my small bowl. However, when you put pressure on it, it gets a very high viscosity and it starts to behave like a solid. So once again, if I hit this hard, I can't get my hand in, but if I just leave my hand in there, it flows up like a liquid. But if I try to pick my hand out too fast, I'll get chunks, right? So while you're playing with your Oobleck, you can play around with how the amount of pressure on it relates to how hard it is, right? So if I squish back and forth, I get a solid ball for a second there before it starts flowing again, right? That's pretty interesting. Now, I would love to hear your favorite thing about Oobleck and your favorite thing about this experiment, and whether you've made it before. I hope you guys really enjoyed this experiment today, and that you'll tune in next week to make Cloud in a Jar on STEM with Simba. Thanks for watching, guys!